All right, guys, let's look at lesson 3, which is predicting products of chemical reactions. So let's look at, there are 3 main steps to writing a reaction. The first step is to identify the type of reaction that we're talking about first, or the type of reaction that the 2 reactants or the reactant will undergo. Remember, we talked about these in lesson 1. There are 5 of them: synthesis, decomposition, single replacement, double replacement, and combustion. These are the 5 main types that you're going to be utilizing in this lesson to predict products. Step number 2 is to predict products or the product using the reaction type as a model. So if you think the reaction is going to undergo a synthesis reaction, you're going to want to use a synthesis equation as a model to write the new equation. And then, as always, you have to balance the reaction. Okay, remember, there are 7 elements that appear in nature as diatomic molecules: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. If you have any one of these in your equation, these are the correct formulas for those. So H2, N2, O2, F2, Cl2, Br2, and I2. They're all your 7 diatomic elements. So let's look at synthesis reaction first. Remember, the formula is A plus X gives you some compound AX. So you have an element plus another element giving you a more complex thing. So a reactant plus another reactant is going to give us a product. So let's look at this example. Write the balanced chemical equation for the reaction of sodium metal and chlorine gas. So first you start off with, what is the reaction with sodium metal? So what does sodium metal look like? So that's Na solid. And it says reacts with, so it's going to be a plus sign, and then chlorine gas. Chlorine is one of the 7 diatomic molecules, so it'll be Cl2. And remember, the S stands for solid, the G stands for gas, and that is going to produce something. Now, this is a synthesis reaction. You have an element plus another element, and it's going to give you one product. What happens when sodium and chlorine combine together? They make sodium chloride, NaCl. You're going to have to go back to your Unit 8 notes in bonding to figure out how to make that compound. Now, when we're going to balance this, we have to check. Do we have 1 sodium on the left? Yes, we do. Do we have 1 sodium on the right? Yes, we do. We have 2 chlorines on the left, so we're going to have to put a 2 in front of NaCl on the right in order to make it balanced. But when we do that, that does not make our sodiums balanced anymore. So we also have to put a 2 in front of Na on the left. Our equation is now balanced. It is written correctly. And does it follow that form? Do we have some element A plus another element X giving us a compound? Yes, we do. So that is a good example, and that's how you would write a synthesis reaction. Let's look at a decomposition reaction. A decomposition reaction, remember, has some compound AX that's going to break down into some element A plus some element X. So you're going to have 1 reactant breaking down into 2 products. Always. That's a decomposition reaction. Now for this, there are a couple of exceptions. There are 2 ways that you can do a decomposition reaction. The big one that I want you to focus on is the following: carbonates. Carbonates are a special case, and the fact that they do not produce 2 elements. When a carbonate decomposes, it will produce a carbon dioxide, so it'll always break down into carbon dioxide, and a metal oxide. So let's look at this example. This is calcium carbonate. When this breaks down, it produces carbon dioxide gas and a metal oxide. The metal in this equation is calcium, so it's going to produce calcium oxide. There are some other special cases, but we're not going to explore those in this class. So let's look at an example. Write the balanced chemical equation for the decomposition of lead 4 oxide. Well, the biggest thing to start off with is you need to write lead 4 oxide correctly first. The formula for lead 4 oxide is PbO2. That is a solid, and that is going to break down. We're doing a decomposition reaction, So that is going to break down into two smaller pieces. Now, since this is not a carbonate, okay, this is not going to break down into carbon dioxide plus a metal oxide. This will just break down into the two elements that make up lead 4 oxide. So it'll break down into oxygen gas plus lead. Now we're going to go through and check. We have 1 PB on the left, we have 1 PB on the right. We have 2 oxygens on the left and we have 2 oxygens on the right. Does this follow this general formula that we have for a decomposition reaction? Absolutely. We have a compound decomposing into 2 elements. So it does, and it is balanced, so that is a correct way to write the decomposition of lead 4 oxide. Now let's look at one where we have to use a carbonate for an example. So the first thing you're going to have to do is write the correct formula for barium carbonate. The correct formula using table E in your reference packet is BaCO3. Now that is going to break down, and that is going to make carbon dioxide gas plus a metal oxide. The metal in this case is barium, and it's going to be barium oxide. So now we have to check and make sure we're balanced. We have 1 Ba on the left, we have 1 Ba on the right. We're balanced with Bas. We have 1 C on the left, we have 1 C on the right, so that's balanced. We have 3 oxygens on the left, we have 3 oxygens on the right, so that is balanced. And that follows the formula for a carbonate decomposition. The carbonate breaks into CO2 gas plus a metal oxide. So that is right. So that one is finished, and it is also balanced. Now let's look at combustion reaction. There are 2 forms of combustion reactions that you can see. The first one is when you have a hydrocarbon. That is a compound that has hydrogen and carbon in it, reacting with oxygen, and it will always form carbon dioxide and water. The second kind of combustion reaction you could have is an element reacting with oxygen to create an element oxide. Products for a carbon-hydrogen compound are always carbon dioxide and water or an oxide. Always, always, always. Those never change. So let's look at 2 examples. We're going to do an example of each. So first, let's look for write the balanced chemical equation for the combustion of tricarbon octahydride. So the first thing you have to do is remember, what does tricarbon octahydride look like? You should be very comfortable and understand that it's C3H8. That's going to react with oxygen gas. And since we have a carbon-hydrogen thing here, plus oxygen gas, the only thing it will make, always, 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 is carbon dioxide and water. Now we have to balance this. So how would we balance this equation? The first thing we want to do is balance for our carbons. We have 3 carbons on the left. We need to have 3 carbons on the right. We have 8 hydrogens on the left, and we need 8 hydrogens on the right. So we have 8 hydrogens on the right now. Now we have to balance for our oxygens. So 3 times 2 is 6, plus the 4 oxygens and water, that's 10. That means that we need to put a 5 in front of O2, so we now have 10 oxygens on the left as well. This is a balanced chemical equation that is written correctly, and it follows the basic form for a combustion reaction when we have a hydrocarbon. A hydrocarbon plus oxygen gives us carbon dioxide and water. Let's look at example 5. Write the balanced chemical equation for the combustion of sodium metal. So this means that we're going to have sodium metal reacting with oxygen to make sodium oxide. Remember, you're going to have to do, this is an ionic compound, you're going to have to use your charges and crisscross to get the correct formula. Now we have to balance. We're going to need to put a 2 in front of Na2O2, Na2O, in order to get 4 oxygens, and we're also going to have to put a 4 in front of Na in order for us to get 4 sodiums. So we have 2 times 2 is 4, so we need to put a 4 in front of Na to have 4 sodiums over here. We have 2 oxygens here, we need to have 2 oxygens here. So does this follow the element plus oxygen to give an element oxide? Is this the element's oxide? Yes, it is. And it is balanced, so that is correct. Now let's look at a single replacement reaction. Now this can happen two ways. Metals can replace a metal, or nonmetals can replace a nonmetal. So if a metal replaces a metal, it's going to have this generic form. And if a nonmetal replaces a nonmetal, then it's going to have this generic form. We're going to do an example of each. So before we do these examples, you have to remember, you're going to have to look at Table J. Table J is the activity series, and that will tell you if these elements will switch places or not. So in this example, remember, if the metal is higher on the list, it will replace anything beneath it. Same thing with the halogens. If the nonmetal is higher on the list, it's more active and will replace anything beneath it. So as long as whatever's coming in to switch is higher up on the list, these reactions will happen. So we're going to write a balanced chemical equation for the reaction of zinc metal with aqueous hydrochloric acid. And hydrochloric acid is HCl. So we're going to start off with zinc metal plus hydrochloric acid. Now zinc is higher than H on the activity series. So zinc will replace H. And when that happens, we get ZnCl2, zinc 2 chloride, plus hydrogen gas. Now remember, the zinc is coming in and kicking out the hydrogen. You can't have just an H floating around out here because it's H is one of those diatomic molecules. So it needs to be H2 when you write your equation. So now we have to balance. In order to balance this, we need to put a 2 in front of HCl. And by doing that, we're going to have 2 H's, and we have 2 H's, 2 Cl's, and we have 2 Cl's. So does this follow the metal replacing a metal? Zinc is a metal. It's replacing hydrogen, which in this case is acting like a metal. The equation is balanced, and it follows the format, so we're okay. Let's look at example 7. Now this is when a nonmetal is going to switch places. So it says, write the balanced chemical equation for the reaction of sodium chloride solid reacting with fluorine gas. So sodium chloride is NaCl. Fluorine gas is one of the 7 diatomic molecules. So it has to be F2. And you can tell because it says fluorine, which is the elemental form. So it's F2. And what's going to happen in here is Cl is going to be replaced by F. So in order for this reaction to work, if you look at Table J, your activity series, F has to be higher than Cl. And if you look, F is on top of Cl, so this reaction will happen and F will switch places. So you're going to make sodium fluoride plus chlorine gas. Now chlorine gas is a diatomic molecule, so it's Cl2. Now we have to balance this. In order to balance this, we need to place a 2 in front of NaF and a 2 in front of NaCl. Now this follows the correct structure backbone for this type of equation, which is a compound plus a nonmetal element will give a new compound plus a nonmetal element. And that's what we have, and it is balanced, so we're okay. Now what we're going to do is we're going to look at a double replacement reaction. Now double replacement reactions can be a little tricky, so we're going to go through it very slow. So these happen when metals replace metals in a compound and nonmetals replace nonmetals in a compound. So you're going to end up with a compound plus a compound, and that's going to make a new compound product plus a new compound product. Remember, these guys are going to switch partners. Think about what we talked about in class when we talked about the dance. They switched partners. So think about it this way. When you're predicting products for these, you're going to do FOIL like in algebra. The outside ions are going to go together, and then the inside ions are going to go together. So when this produces a new product, Ag is going to go with Cl, and then NO3 is going to go with Na. The one thing that students always get confused about is they want to write NO3 first. You can't do that. You always have to write your metal atom first. So it'll be NaNO3. So let's do an example. Write the balanced chemical equation for aqueous potassium sulfate and aqueous barium nitrate. The big thing with these also is you have to write your equations correctly first. So you're going to start off with potassium sulfate plus barium nitrate. And you're going to make what two products? Well, we're going to do the inside guys together first. So it's barium sulfate. Remember, your Ba has to go first because it's the metal. And then we're going to make the two outer things are going to come together. So potassium nitrate. Now we have to balance. Okay? K, 1K here, 1K there, we're okay. We have a Ba, 1Ba, 1Ba, we're okay. One SO4 group, one SO4 group, okay? We have two NO3 groups over here, so we're going to have to put two NO3 groups over here, okay? So when we have finished and it's correct, that's what it should look like. So let's look at your practice. So pause the video, try all of these, and then we'll check them when you're finished. Great, well, welcome back. What should you have gotten? So we have H2SO4 plus NaOH. That will make H2O plus Na2SO4. And in order to balance, we're going to have to stick a 2 in front of NaOH and a 2 in front of H2O. We have number 2, KOH plus CuSO4. That's going to make CuOH2 plus K2SO4. Both of these, 1 and 2, are following the double replacement reaction equation. So then we're going to have to balance these, and that's what you should get. Okay, 2KOH plus CuSO4 gives you CuOH2 plus K2SO4. Now we have FeCl3 plus NaOH. Again, this is going to follow the double displacement. So we're going to get FeOH3 plus NaCl. We have to balance, so we're going to need to put a 3 in front of NaCl and a 3 in front of NaOH. And now that is balanced. This is going to undergo a single replacement because we have an element and a compound. So the K is higher than Mg on the table, so K is going to be able to come in and kick Mg out. So we're going to have Mg plus KBr. And when we balance, we have to put a 2 in front of KBr. Now let's look at the last one. This is a decomposition reaction, but it has carbonate in it. So remember, when you see these kinds of reactions and you have to predict your product, you have to think, this is a carbonate. It produces only two things, carbon dioxide and the metal oxide. So we have carbon dioxide and then the metal oxide, and this is already balanced, so we don't need to add any coefficients. All right, check your understanding. Try these, and we'll go over these first thing tomorrow morning.